Morning, students. Welcome to another session. This session, we'll be talking about advanced predictive modeling. This is a new unit that we'll be covering within the next few days or few weeks. So the topic is develop models using binary logistics regression and assess their performance. The unit aim. So this unit will introduce you to some of the most widely used predictive modeling techniques and their core principles. Throughout this unit, you will form a solid foundation of predictive analytics, which refers to tools and techniques for building statistical or machine learning models to make predictions based on data. You will learn how to carry out exploratory data analysis to gain insight and prepare data for predictive modeling. So these are the content, indicative content. The first one is latent variable model, probabilistic model, use programming codes for the models, probability distribution, linear predictor, link function, order response, and unordered response is the last one. Also, what are the key terminology? The key terminology includes regressions. Regression problems are prevalent in machine learning, and regression analysis is the most often used techniques for solving them. It is based on data modeling and entails determining the best fit line that passes through all data points with the shortest distance possible between the line and each data point. While there are other techniques for regression analysis, linear and logistic regression are the most widely used. Ultimately, the type of regression analysis model we adopt will be determined by the nature of the data. So you may be asking yourself that what is the purpose of regression model? Well, regression analysis is used for one of two purposes. Predicting the value of the dependent variable when informing about the independent variable. When information about the independent variable is known, or predicting the effects of an independent variable on the dependent variable. What is regression analysis? Predictive modeling techniques such as regression analysis may be used to determine the relationship between a data set dependent goal and independent variables. It is widely used when the dependent and independent variables are linked in a linear or non-linear fashion, and the target variable has a set of continuous values. Regression analysis, for example, is the best way to examine the relationship between sales and advertising expenditures for a corporation. Types of regression analysis. There are numerous regression analysis approaches available for making predictions. Additionally, the choice of technique is determined by various parameters, including the number of independent variables, the form of the regression line, and the type of dependent variable. What is linear regression? The most extensively used modeling technique is linear regression, which assumes a linear connection between a dependent variable y and an independent variable x. It employs a regression line, also known as best fit line. So over here, over this chart, we can see that we have the linear regression and we have the data scattered across each axis. So the linear connection is defined as y is equal to c plus m times x plus e, where c denotes the intercept M denotes the slope of the line, and E is the error term. 2, the linear regression model can be simple with only one dependent and one independent variable, or complex with numerous dependent and independent variables, with one dependent variable and more than one independent variable. We can obviously Google what this means to better understand it. 2, in case you are wondering that, oh, how can I know more about this linear regression? There are loads of web links available for you to take a look at, like this one, talking about the regression model and the formula that literally we're just talking about right now. The next one is logistic regression. When the dependent variable is discrete, the logistic regression technique is applicable. We can see it in this chart below. You can see the test passed and the hours studied. More on logistic regression. In other words, this technique is used to compute the probability of mutually exclusive occurrence, such as pass or fail, true or false, 0 and 1, and so forth. The target variable can take on only one of two values, and a sigmoid curve represents connection to the independent variable and probability as a value between 0 and 1. We can also check what logistic regression means. This is a book, but obviously, you can check the IBM website for this. Yeah, so this provides us a detailed type of logistic regression, among other things like the use case is used for fraud detection, disease prediction, and churn prediction. The next one is polynomial regression. The technique of polynomial regression analysis is used to represent a nonlinear relationship between dependent and independent variables. It is a variant of the multiple linear regression model, except that the best fit line is curved rather than straight. So that is the difference between, give us a second. That's the difference between linear regression and polynomial regression. So let's say it is a variant of the multiple linear regression model, except that the best fit line is curved rather than straight. Ridge regression. When data exhibits multicollinearity, that is the ridge regression technique. That is, the ridge regression technique is applied when the independent variables are highly correlated. We can see the formula here, and also we can see the chart showing what ridge regression is. The explanation: why least squares estimates are unbiased in multicollinearity, their variances are significant enough to cause the observed values to diverge from the actual value. Ridge regression reduces standard errors by biasing the regression estimates. The lambda, this is the symbol of lambda, variable in the ridge regression equation resolves the multicollinearity problem. Also, we have lasso regression. As with ridge regression, the lasso, which means least absolute shrinkage and selection operator techniques, penalizes the absolute magnitude of the regression coefficient. Secondly, additionally, the lasso regression technique employs variable selection, which leads to the shrinkage of coefficient values to absolute 0. we can see the charts showing what ridge regression is and also showing what lasso regression is. Excuse me. Excuse me. Showing what ridge regression is and also showing what lasso regression is. Now, I see the difference between the chart and all. We also have quantile regression. The quantile regression approach is a subset of the linear regression technique. It is employed when the linear regression requirements are not met or when the data contains outliers in statistics and econometrics. Quantile regression is used. We also have Bayesian linear regression. Bayesian linear regression is a form, excuse me, yeah, sorry about that. Bayesian linear regression is a form of regression analysis technique used in machine learning that uses Bayes' theorem to calculate the regression coefficient values. Secondly, rather than determining the least squares, this technique determines the feature's posterior distribution. As a result, the approach outperforms ordinary linear regression in terms of stability. So we can see the chart showing Bayesian linear regression. The red one is the true regression line, and the blue one or the purple one is the Bayesian linear regression. Principal, give us a second. Principal component regression. Firstly, the multicollinear regression data is often evaluated using the principal component regression approach. Secondly, the significant component regression approach, like ridge regression, reduces standard errors by biasing the regression estimates. Principal component analysis is used first to modify the training data, and then the resulting transform sample are used to train the regressors. The next one is partial least squares regression. So what is partial least square regression? This type of regression technique is a fast and efficient covariance-based regression analysis technique. It is advantageous for regression problems with many independent variables with a high probability of multicollinearity between the variables. The method decreases the number of variables to a manageable number of predictors, then it's utilized in a regression. Elastic net regression. So in this example, we have the lasso coefficient, elastic net coefficient, S lasso coefficient, and SRF coefficient parts. This chart differentiates both of them for us. The explanation. Elastic net regression combines ridge and lasso regression techniques that are particularly useful when dealing with strongly correlated data. It regularizes regression models by utilizing the penalty associated with the ridge and lasso regression methods. So, after talking about all these type of regression methods, we have to understand what we're talking about. So this here is a summary explaining everything. Machine learning employs a variety of other regression models such as ecological regression, stepwise regression, jackknife regression, and robust regression. In addition to the ones discussed above, for each of these various regression techniques, know how much precision may be gained from the provided data. In general, regression analysis provides two significant advantages, and these include the following. It denotes the relationship between two variables, one dependent and one independent. It demonstrates the magnitude of an independent variable's effect on a dependent variable. As we all know, you need to, if you have any question, refer to our journals and articles or ebooks for this unit, and send us any question that you have or any queries to the email seen above. And also don't forget that assignment submission is after 2 weeks of the completion of the unit and its delivery. So thank you for attending the class today. But just for recap, the new topic today is advanced predictive modeling. So we need to learn how to develop models using binary logistic regression and assess their performance. We'll talk about the unit aim, the key terminology, and the purpose of regression model. We spoke about what regression analysis is, the types of regression analysis. We started by talking about linear regression, among other ones, to logistic regression, to Bayesian regression, ridge regression, lasso regression, alien linear regression, and elastic net regression. If you have any question, if you have any worry about what we've spoken about today, you can obviously Google it to know more about it. Take, for example, the elastic net. This popular website talks about what it is for us, but we can obviously see a video on linear regression. Since a video was not provided for this class, I decided to give us a video instead talking about it. So let's watch this video before we end the class.
With Klaviyo, it's easy to power smarter digital relationships and turn your customer data.
This tutorial is an introduction to regression. There's an X variable and a Y variable in this case. The independent variable is on the X-axis and the dependent variable is on the Y-axis. And we try to form a relationship between these two variables and draw a line, in this case, a straight line. And over the next series of videos, I'll explain what all this means. What we try to understand is as the independent variable is moving or changing, what happens to the dependent variable? Does it go up or does it go down? How does it change? If they move in the same direction, if the independent variable increases and the dependent variable increases as well, like this, we say there's a positive relationship. If, on the other hand, as the independent variable increases and the dependent variable decreases like this, we say there's a negative relationship. The line would look like this, go downward. In linear regression, we try to make a line to make a linear regression. The key is on line right there, a straight line. You can also do curved lines, but for this topic, it's all straight lines. To actually conduct regression, I take observations, and I'll just plot some more observations in here randomly. I'll stick them in here like that. And I try to find a line that will fit, a straight line that fits through all these different points. And this is called my regression line. And it's based upon the least squares method. And in the end, I want to minimize the difference between the estimated value and the actual value. I want to minimize my errors. This line will have a lot of errors if I compare the actual to the estimated value. And again, the point is to minimize these errors or make them as small as possible. Now let's imagine I put study time on the X-axis, or make that my independent variable, and the dependent variable becomes grades or GPA. As study time increases, grades should go up. There is a positive relationship. In regression, we develop these equations like this. In this case, y hat is estimated grades, and it's based upon, or it's equal to, b naught plus b1 times x, where x is study time. B naught we derive mathematically, and it is the y-intercept. B1 we also derive mathematically, and I'll do it in a later video, and it's the slope of the line. In this case, the slope is positive. In the next video, I'll discuss how you develop these equations. Now, if I change the x-axis to time on Facebook, we see a negative relationship. More time on Facebook, grades will suffer and go down, a negative relationship. What we're estimating is still grades. Estimated grades is equal to b naught minus b1 times x, where x is time on Facebook. B naught is still the y-intercept. The y-intercept. And it is a calculated value. The slope of the line is negative b1 because it's downward sloping, negative relationship. And as I said before, I'll show you how to calculate this equation in the next video. The x is the independent variable. The y is the dependent variable. The x is what we control, what we manipulate, what we change. And the dependent variable is the outcome. So study time is the independent variable. It's what we control and manipulate. And your grades are dependent upon how much you study. Now this looks really ugly, and it's what I'll talk about in the next video, but I'll step you step by step through it and I'll hopefully make it simple for you.
So let's bring end to our class today. Tomorrow, we'll be looking at the other topic. Thank you for attending, and I'll see you tomorrow.